Hi, and welcome to the screencast on the axial skeleton. This should be quick, like 10 minutes or less. So the first thing we want to talk about are your paranasal sinuses. So we'll look at this picture while we talk about your paranasal sinuses. So these are holes inside some of your skull bones that are lined with a mucous membrane and filled with air. They lighten your skull and help add some resonance to your voice. What you need to know is the four bones that contain sinuses. So the frontal bone, ethmoid bone, sphenoid bone, and maxillary bone. These are the things that hurt when you get a sinus headache. They are connected to your nasal cavity, so viruses that have infected your nose or lungs that are in your respiratory membrane can also get into the mucous membrane that lines these cavities, and when they become inflamed, they don't drain as easily, so pressure builds up and you get that sinus headache. I'm not going to ask you anything about the hyoid bone, so let's just skip it. Then we get to the vertebral column. This is, or I should say there is, a possible open-ended question about the vertebral column, which is you need to be able to list the four curvatures of the vertebral column and explain or say what physical properties they impart to the spine. So there are four curvatures. You need to be able to list them: cervical, thoracic, lumbar, and sacral. And then you need to be able to say that collectively those four curvatures add strength and flexibility to your vertebral column. The flexibility part comes in where, so here's what your vertebral column looks like from the side. Imagine that it looked the same way as it does from the side as it does from the front. So straight up and down, it's just a straight rod. The only compression you would get from it, or flexibility you would have, is the flexibility that each of the intervertebral discs give you. So if you tried to just compress it, like put a weight on top of it, it wouldn't be that springy. But because the discs are flexible and you have the curvatures, all the curvatures can bow out in one direction or another, so that when forces are imparted to your vertebral column, the curves can expand and contract to absorb some of that force. Now this also adds flexibility because, not flexibility, strength, because again, if your vertebral column looked straight up and down from the side and the front, it would be a little unstable, right? So the intervertebral discs are still a little bit flexible. So if it got out of alignment at all and started to bend, right, you would just get one big curve in your vertebral column, and then all of the force being applied to the vertebral column would be felt right in the middle of that curve. So if you took like a very narrow, long twig and compressed it between your hands, it would bend in the middle, and then it would snap in the middle because that's where all the force is felt. If you have, multiple curvatures, then you get a little bend here, a little bend there, and a little bend here, and that also spreads the forces out and reduces the total amount of force that is felt by any one part of your vertebral column, so it's less likely to fail under load. There are three different types of abnormal spinal curvatures, or sort of deviations from normal. You just need to know their definitions. So scoliosis, as this says right here, is any abnormal lateral curvature, or really any lateral curvature. Your vertebral column is supposed to go straight up and down when viewed from the back like this. So any deviations from the midline is scoliosis. Kyphosis is simply an exaggerated thoracic curvature, so you get that humpback or hunchback shaped. I'm not sure exactly what causes kyphosis. It depends on different reasons in different people. Here is a young man with kyphosis, x-rays, and then the surgery to correct. And I'm moving so quickly I forgot to point out the same thing in the young person with scoliosis. But you don't need to know how to do the surgery to correct. Then lordosis is simply, as this shows right here, an exaggerated lumbar curvature. And that's all you need to know about it. Okay, so then there are 3 ligaments that you need to know. So this is possible anatomy pictures which may show up on the next lecture exam. So right here is your anterior longitudinal ligament. It runs all the way down the front of your vertebral column. And a little bit harder to see right here is your posterior longitudinal ligament, which runs down the posterior length of your vertebral column, top to bottom. Then you have your ligamentum flavum, which is these 2 things right here and that thing right there, which just runs from what is called the lamina. So this is the part that's going out towards the transverse process. But you don't need to know that, you just need to be able to identify them. And then the third is the interspinous ligament, which is these things here and here and here, which just run from one spinous process to the other. Moving right along, looking at the intervertebral discs, you simply want to know what they are composed of. So you want to know that the inside is the nucleus pulposus, which is gelatinous and compressible, so it's relatively tough, but more oozy and gelatinous than the outside, which is the annulus fibrosus, and that is made out of fibrocartilage, is what you're supposed to write in there. So that's your intervertebral disc, and then the arches of the foot we just don't care about. They will not be on the exam. That's it in 7 minutes for everything from Chapter 7 that would be on a lecture exam.